So we currently have all of they're called kinematics equations, the study of motion, all of the equations that you will need basically to solve any problem that involves moving objects. Velocity equals distance over time. That is the relationship for either constant or average velocity, okay? This really, you don't need to know that, all right. Change in velocity over time is acceleration, and we always do final minus initial. The reason for that is it sets up the positives and negatives. We have this equation. And this one. Did anybody do the extra credit? Okay, good. I'll check that a little bit later. Okay. So those are our 4 kinematics equations, and we're going to use those all year, pretty much. They will always be on the board. You do not have to memorize them, but I promise you, you probably will. Okay? So I'm going to set this aside, and what I'd like you to do is go through the following exercise discussion with me, and just use, I'm going to use easy numbers, so I want you to just use sort of let's do this with head math. We're going to check in with each other and see if you can do this without even thinking about those formulas, okay? And if you would like, I will take a picture of this when we're all done and post it so that you don't have to copy down the notes. You can just kind of relax and enjoy this, all right? So we have a cliff. It's pretty high. And let's see, at the top of the cliff, that's a really long bill on his hat. Okay? And he's going to take a ball, and he's going to throw the ball up with an initial velocity of 10 meters per second. Gravity will do what to the ball?
Pull it down.
Yeah, it wants to pull it down. And acceleration due to gravity for this discussion is going to be negative 10 meters per second squared. The negative designating the downward direction. So gravity pulls stuff down. When I have a negative acceleration and a positive velocity, what will the negative and the positive do to one another? Yes, cancel each other out. They'll have a negating or an opposing effect. So the ball will slow down until it reaches the peak of flight. Now, we're not going to give it much horizontal velocity, but I'm going to scooch it over just for visual purposes. But imagine that it's just going to go straight up and straight down, okay? At the peak of flight, 1 second later, what is the velocity of the ball? 0. Yes. Right. And then it's going to start falling. And what's going to happen as it starts falling to its speed or velocity? The number value, what's going to happen to the speed? It's going to get bigger. So this is a 1 second time interval. It takes 1 second to go from 10 up to 0, and then it's 1 second later again. So what's the velocity right here? Negative 10, that's correct. So the velocity here is negative 10 meters per second. And does that make sense? From this number, it changes by 10 meters per second every second.
Do you have to add the square to it?
Well, where are you talking about the square? Like over here?
Yeah.
These are velocity numbers. So the velocities are just meters per second. That's a good question. Acceleration is meters per second. Okay. 1 second later, how fast? Very good. Now, these are all going to be 1 second time intervals. 1 second later, how fast? Yeah, thank you for the negative. 1 second later, how fast? Yep. Okay. What's the acceleration here? What did you use to figure this out? What's the acceleration as it falls? It's right on the picture. -10, yeah. What's the acceleration right here? -10. What's the acceleration right here? -10. What's the acceleration right here? -10. Very good. You are getting this. What's the acceleration at this exact moment when it's at the peak of flight?
0.
0. What's the acceleration right here? It's still -10. Good. That's correct. Who was that over here? Lauren and Rachel. I heard girls' voice. Oh, dang it, she's throwing her voice. All right. Thank you. This is also -10. It's just that when you have a positive velocity, what does a negative acceleration do? Slows it down, brings it to 0. When you have negative velocities, what does negative acceleration do? Go faster, right? So, acceleration here, -10, -10, -10, -10, 0 at the peak, and -10. There's one wrong answer in that. One of these things is not like the other. Where is it? 0. It's at the 0 spot. Think about this. What makes this acceleration -10? What's the cause?
Gravity.
Yes, the Earth. What's the cause of this acceleration?
Gravity. Force of them throwing.
No, what's the cause of the deceleration, not the initial force? Yeah, stop being so smart. It's all gravity, all the time, all Oh, except for there, where gravity selectively decides, I'm not going to do anything just for that split second. Come on, gravity doesn't do that, right? So what's the acceleration at that moment? -10. Isn't that weird to think about? When the ball stops at the peak of flight, gravity shut off? No. When it stops, it has an acceleration. How can you have an acceleration when your velocity is 0? So what's happening at that spot? Gravity isn't necessarily making it go with speed. What's it doing at that moment? Switching the direction. Well done. That's correct. It's a direction changer. And we're going to talk about well, we can do this right now. Acceleration is change in velocity over time. And what did we say about velocity? What two characteristics does velocity have? Direction and the number value, right? Speed. Okay? So, could you accelerate something by changing either of those two characteristics? By changing speed, can you accelerate or decelerate an object by changing its speed? Yes. Can you accelerate or decelerate an object by changing its direction? Yes. You guys have all experienced this. In the car, remember we were talking about like when your mom takes a sharp turn and you squish your little brother against the side of the car. You can maintain the speed around a curve, right? Like keep the cruise control on and take a turn. Can you feel a force when that happens? Are you changing your speed when that happens? Cruise control is set? No. Are you accelerating when that happens due to a change in direction? The answer starts with a Y. Yeah. You can accelerate by either changing your speed, the number value, speed up or slow down, or change direction, and so that's what's happening there. All right. Now let's check out distance. Again, we're not using any formulas, we're just like using our intuition. So these are all 1 second time intervals. 1 second intervals. The distance from when he releases the ball at positive 10 meters per second to 0, what distance, if that's a 1 second time interval, how far? 10 meters makes lots of sense. The answer is not 10. It's 5. Why? We talked a little bit about this yesterday. average velocity. So between 10 and 0, the average velocity is 5 meters. So that's how far, 5 meters. Okay? Now, I drew it on this side. Is it 5 meters slowing down and 5 meters speeding up? Yes, it is. How about in this, so there's the first, second, in the third second, this is a 1 second time interval, it goes from 10 to 20. What's the average speed in between these? 15, so how far? 15 meters. Technically, this should be negative down and positive up here. Positive 5 meters. That'll be negative 15 meters. All right. I want you to do these in your head, then share with your shoulder partner or partners. If you're in the middle, you got to do 2. See if you agree, and then we're all going to shout it out. So in your head. Now with your shoulder partners. Okay, and middle kids, you got to go both ways, right? Both shoulders. All right. On the count of 3, I want to know what this distance is. 1, 2, 3. -25. Yeah, it was just so on the timing. All right. On the count of 3, it's actually not really on the count of 3. It's like on 4. It's just like rock, paper, scissors, right?
On go.
Right. Is it on shoot or on go, whatever, whatever the local custom is. It's never on 3. Who does it on 3? You know what I'm talking about? Is it 1, 2, 3, shoot? Yeah, it's not 1, 2, shoot. No, who does that? So, same thing with on 3. Got it? Ready? 1, 2, 3. Who was too quick over here? Really? With all that music background? Oh my gosh. Okay. You did that without any formulas, right? So formulas are a guide to thinking. We're using easy numbers here, so you don't have to have a calculator. Well, you do have a calculator. Okay. So if you understand this, that's like using everything, all of those equations, those 4 equations that we learned together. Okay? All righty. We could check a couple of these. That would be kind of fun. Let's check this one. Velocity equals distance over time. That's probably really what you use to solve for all those distances. So velocity equals distance over time. What's the average velocity here between these two? Yeah, -25. And the time interval, 1 second. So obviously 25 is the distance. Let's do like a 2 second time interval. The average velocity from between 10 and 30 is 20. So if you're going 20 meters per second for 2 seconds, how far is that? Yeah, 20 meters per second times 2 seconds is 40. Is 15 plus 25 40? You betcha. All right, let's look at another equation. Acceleration equals change in velocity over time. Acceleration is gravity. So no matter where we solve for acceleration in this picture, what should we always get? -10. So it's final minus initial over time. So let's pick 2 spots. Let's pick these 2 spots right here. So final velocity minus initial velocity over time. -20 minus 0, what's the change in velocity? -20, right? -20 minus 0. And how much time? 2 seconds. What's -20 divided by 2? -10. Bam, baby. Let's pick 2 more difficult spots. -40 minus the initial velocity minus -20. -40 minus -20 is -20, right? Right, because it's like saying plus 20 divided by 2 seconds. -10. Are you seeing how this works? How about this one? Distance equals 1. All right. Let's go from the tippity top down to so like a 3 second time interval. Let's solve for distance. 1/2 AT squared. 1/2 times 10. -5 times time squared. 1/2 times -10 times 1, 2, 3 squared. What's that? Can you do that in your head? Yep, -45. Let's do this one. This one we might need to write out just a little bit. So distance equals 1/2 times -10 times 3 squared. And then what's the initial velocity at the tippity top? 0. So all done with that part, right? 0. That goes bye-bye. What's all this? Is that correct from here to here? 5 plus 15 plus 25, -45? Woohoo! All right, let's do the last equation. Final velocity squared equals 2AF plus initial velocity squared. Final velocity squared. Pick two spots. 0 and 10. You want to pick those? Okay. You want to do these two? Okay, all right. So final velocity would be what in this picture, Manraj? 0. What's the acceleration always? -10. What's the distance traveled between those two? 5 meters. What's the initial velocity when he released the ball? +10 meters per second. Okay? What's all this? What's 2 times -10 times 5? -100. What's 10 squared? +100. What does it equal? Yee-hee! See? They all work. All right. I'm going to stop the video, and I will also take a picture of this, and that will be posted online on today's calendar.
Can you have
Sound good?
sticky notes in the picture?
You want me to put the sticky notes in? Sure.